quadratic equations using our fourth and final method. To activate your thinking, take a look at the three equations that appear on your screen. First, we have the quantity x plus 5 times the quantity x minus 2. Second, we have the quantity x minus 2 squared equals 25. And lastly, we have 3x squared minus 5x plus 0.5 equals 0. I have two questions. The first is, which of these functions would you prefer to solve? And the second is, which would you like to avoid? Think about why. You can pause the video here if you need to think. My guess is that you chose either the first or the second equation. The reason that the first equation is easy is because it is already factored and equal to 0. The second equation can be solved by square roots, which is the last thing that we learned. The third equation, on the other hand, is likely the one that you chose that you would like to avoid. Here are some reasons why you might want to avoid it. It can't be factored. It's not in vertex form. It can't be put into vertex form easily by completing the square because we have that -5 as the coefficient for x. And the graph shows that it has decimal intercepts. So even if you wanted to approach this one by graphing, if you take a look at the graph here, it's not crossing at an integer interval. It might be a decimal. It's not easy to work with. So let's say that you went into the first one. You can look at that and you already know your answers. It's -5 and -2. For the second one, it's a little bit more work, but you take the square root of both sides. Don't forget to minus. Then x equals 2 plus or minus 5. So x equals -3 or x equals 7. You might be wondering now, how am I supposed to approach this last problem? Well, don't worry, because we have one more tool for you. We are introducing the quadratic formula. The quadratic formula can be used to solve any quadratic in standard form. You just have to be able to identify a, b, and c. So if you have your quadratic, it's in standard form, it's equal to 0, and you have ax squared plus bx plus c. You're just going to plug a, b, and c into this beautiful formula. X squared equals -b plus or minus the square root of b squared minus 4ac all over the quantity of 2 times a, the quadratic formula. So here's what we're going to do. Let's say that we took our equation from the last slide, 3x squared minus 5x plus 0.5. What we would do is we would plug in the 3 everywhere we saw a, plug in the -5 everywhere we saw b, -5, and plug in the 0.5 everywhere you saw c, which is actually only once. You might begin to worry that you need to memorize this, but don't worry, you don't need to memorize this formula. It's going to be provided for you anytime you need to use it. But if you wanted to memorize it, you could, and if you stay till the end, we have a little trick for you to memorize it. You also might be wondering, what is this formula? Where does it come from? What's happening? What is this? However, it is actually related to completing the square. So if you take a look at this, on the left-hand side, we have an equation with numerical coefficients 2, 12, and 10. We can show that if we complete the square on the left-hand side there, if you use variables instead of the coefficients, using a, b, and c to stand in for 2, 12, and 10, what you do when you complete the square is really the quadratic formula. It's completing the square to any standard form equation. So let's try an example together. You have a digital capture sheet that was provided as a Google Doc. You can make a copy of that and type in it, or you can print it and write on it if you prefer. So here's our first example. X squared plus 5x minus 14. So this is in the form ax squared plus bx plus c. So let's highlight our a, b, and c value. A is 1, b is 5, and c is -14. Be careful, make sure you include that negative. So in the boxes on your capture sheet, you're gonna fill in A is 1, B is 5, C is -14. And we're gonna plug those in to our quadratic formula. So A goes in for A, B goes in for B, C goes in for C. When you replace them, use parentheses when you put each value in. You can pause the video now and fill that in. When you're done, it should look like this. So x equals -5 plus or minus 5 squared minus 4 times 1 times -14 all over 2 times 1. So especially there in that square root sign, you want to make sure that you're plugging this in using parentheses to remind yourself that you are multiplying. Speaking of this section here, this is actually called the discriminant. The second part of our lesson this week is going to focus on the discriminant, what it means and what it can tell you about your quadratic. It's also the place we're going to start simplifying. So now we're going to actually start finding our solutions now that we have this all plugged in. So the first thing we're going to do is simplify what's in that square root, the circled part there. So 5 squared is 25, and 4 times 1 times -14 is 56. So what we're doing is subtracting -56, which ends up adding 56. And it's all over 2, so 2 times 1 is 2, that's my denominator. 25 plus 56 is 81, and now it does kind of look like completing the square, because you have a positive square root of -1 and a negative square root of 81. So that's why we have that plus or minus right here. So I'm going to split this just like I did with completing the square. I'm going to do the addition on the top and the subtraction version on the bottom. So -5 plus 9 over 2 is going the positive version because the square root of 81 is positive 9 or -9, which is 4 divided by 2, which means x equals 2. We got one of our answers. Doing the same thing on the bottom. We have -5 minus 9 this time because the square root of 81 could also be -9. So it's -14 divided by 2, which means x equals -7. So our solutions would be x equals 2 and x equals -7. Wait a minute though. Take a look at this equation again. Did we need to use the quadratic formula? Yeah, we could have just factored that. So all of that work that we just did.
But you did this for what? Why not? Why?
If you can factor it, you don't have to do it that way. So instead, let's take a look at an example like this, where we actually do have to do the quadratic formula. You can't factor it, you can't just put it into vertex form. The answer is not going to come out quite as nicely the last example we chose because it was easier to work with, but now that you're used to working with the formula, let's try something where it was actually necessary. So this is still in the form ax squared plus bx plus c. This is also on the second page of your capture sheet, by the way. So let's highlight those values. A is 3, b is -5, c is 0.5. You can write those into the box on your capture sheet. The next thing we're going to do, of course, is plug them into the quadratic formula. So this time when we plug in b, we have -5, which is going to turn back out to a +5. And just like last time, now that we have this all plugged in, we're going to begin with the discriminant. This is just a reminder, you can always pause this video at any point if you need a little more time to write. So here's our discriminant, and we're going to begin by simplifying in here. So moving down, the first thing we're going to do is our -5 squared, which is +25, and then 4 times 3 times 1/2 is 6. Also 2 times 3 in the denominator becomes 6. Next, we're going to simplify more what's inside our square root there. So this is 5 plus or minus the square root of 19. This is where you will notice that this is a little bit different than our last question. So the square root of 25 came out evenly to be plus or minus 5. That's not what we did last time. The square root of 81 came out evenly to plus or minus 9. Here, the square root of 19 doesn't have an integer value. It is an irrational number. It's a non-repeating decimal. So we'll see what happens here. We're still going to think about this as plus or minus, and we're going to go in two directions here. So our first option is 5 plus the square root of 19 divided by 6, and our second option is 5 minus the square root of 19 divided by 6. As you can see here, the square root of 19 is 4.358898944. Sometimes we actually just leave our answer exactly like this. Like, it's done, just leave it, put a circle around it, 5 plus the square root of 19 over 6 as one of our options. Leave it. That's actually weirdly okay sometimes. The other way we can do this is by rounding the square root of 19 and moving on from there. So let's try rounding. We'll use 4.36, rounding to the nearest hundredths place. When you add that with 5 and then divide by 6, the answer you'll get is 1.56. Not a bad looking answer. The next option is if it was subtraction. So this time we subtract 4.36, which is a rounded version of the square root of 19. It's not exact, but it's close. And this time we get 0.11. So just as before, we have our two answers. These are the rounded decimal versions. You could also use the 5 plus or minus the square root of 19 over 6. So depending on what your teacher asks for, you can leave it in like that radical fraction form, or you can take it all the way and round it out. So that's it for our practice problems here. Hopefully you've learned a little bit about how to use the quadratic formula. But before we leave, you did want to sing it, right? All across the world, teachers, at least the United States, teachers are teaching kids the quadratic formula by singing it to the tune of Pop Goes the Weasel. And we wanted to make sure that you didn't miss out on this incredible opportunity, because just because we're not in school doesn't mean that you shouldn't, get to cringe at your teacher singing to you. Are you ready? I don't think I am. All right, here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There you go. That's your gift from me to you, the quadratic formula. Have a great day.